All right, welcome to lesson. This is kind of a combination lesson. This is more of an 812, 813, 814 type lesson right here. Kind of covering quite a bit in one lesson. Um, you're going to notice I've got my diamond and my generic rectangle here. And you might look, as you look at the two numbers in here, that I'm aligned with letter A is what I'm going through here. The question becomes, how did I get the 18x squared right up here? Well, you might notice what I did with this number and this number is I multiplied those two together to get my 18x squared. Where did the 9x come from? Hey, that's your middle term right there. You might notice over here for the generic rectangle, where did the x squared come from? Well, that's your first term. And where did the 18 come from? That's the last term. Will these two add up to the 9x squared? We'll find out in a moment. All right, so let's do the generic or the diamond over here first. We need two numbers that multiply together to make 18x squared. And we need two numbers at the same time that add up to make 9x. Go ahead and think about that for a moment. When you get to 3x, and over here 6x, both of them being positive, you let me know. I am having technical difficulties if you can't tell. There we go. 3x and 6x. Now it's these two numbers that add up to the 9x. And yes, those are the two numbers that go over here. 3x over here for this one, and 6x that goes in for this square. So please make sure you kind of know where those numbers come from. Make sure you've done your homework to figure that out. Right here, x and 6x. What do these two have in common? What we're doing is we're going to factor out the generic rectangle. They have an x in common. What does the 3x and the 18 have in common? They have a 3 in common. Then, what does the x squared and the 3x have in common? They have an x in common. And 6x and 18 has a 6 in common. You might notice, as we look at this now, I've got an x and a 3 over here, an x and a 6 over here, so this becomes my factored part of this, which is x plus 3 and x plus 6. Does that make sense where those came from? Good. Now, many of you, when we factored before, we've just said, hey, take a look at the factors of 18. As you can see, I've put those over here. 1 and 18 works, 2 and 9 are factors, and 3 and 6 are factors. Well, what factors add up to 9? And those factors over here would be 3 and 6. So we've got the positive 3 here, the positive 6 here. And many of you are going, well, that's way faster. Why can't we do that? Well, here's the issue. And I'm going to move on to a next problem here, which comes right here. Take a look at question 33, letter A. Now I've got the 9x squared minus 12x plus 4. If you wrote down the 4 and you write down the factors of 4, you're either going to get 1 and 4 or 2 and 2. And even if you make them both negative, you will never add up to the negative 12. Well, and that's because it doesn't. But you can still factor this problem. So, for example, let's do the diamond and rectangle. What is 9x squared times 4? Hopefully you're saying that's 36x. And let's see if I get my little squared sign on here. 36x squared. And the middle term, which is a negative 12x, goes right down there. As we said in these two opposite boxes here. And it really doesn't matter if it's these two opposites or these two opposites, as long as they're opposite boxes. The first term, the 9x squared, you gotta get my squared sign on there again. And then the second term, which is our 4, positive 4, goes right there. So now help me out here. Think of some two numbers that multiply to make a positive 36x squared, but add up together to make a negative 12. Let's see here. We've got, let's see here, multiples of 36. Let's see, we've got 36 and 1, that won't work. 18 and 2 will not work. 12 and 3. 12 and 3 doesn't work. We've got 9 and 4 doesn't work. 6 and 6, hey, 6 and 6 work. So on this one, we've got a negative 6x over here and a negative 6x over here. Position those correctly. And we take these two and we plug those two in here. Negative 6x and negative 6x. And now we can factor these out. What does 9x squared and negative 6x have in common? Well, they have a, what's called positive 3x. Positive 3x. And what does negative 6x and 4 have in common? I know it might sound weird, but we're going to call this a negative 2 right here. That will change this number to a positive and this number over here to a negative. That will help us because then this one becomes 3x for this one. And over here, because that 4 is now negative, we get a negative 2 as our factors. So as we factor that one out, we have 3x minus 2, 3x minus 2. So the answer to this one is simply 3x minus 2 times 3x minus 2, or another way of saying that is quantity squared. You'll see from my answer on letter A, there it is right there. Hopefully that makes sense to you. What I would like you to try is try B and C. By the way, notice that C is out of order. You must put it in standard form order first, meaning the x squared comes first, the x's come second, and this number 28 has to come last. So go ahead and pause the video and then come back and try that one. Alright, you should be back. Hopefully, if you did this correctly, you got those two answers for B and C. Now it's letter D. Many of you are going to come up with a different answer, but now let me give you the very first step to factoring each and every time you factor. What you should be doing each and every time you factor. And you can see I'm putting in a little parentheses right here. I need to move those parentheses up. Very first step whenever you factor is see, is there something that I can factor out of the entire equation? Is there? Yeah, you can factor out a 3, can't you? You can see that little 3 put right here. Once you've factored out the 3, you've got n squared plus 3 plus 2. Then you can do your generic rectangle and diamonds, and you get this. What the question becomes is, are there more than one answer to this? If you had left the 3 in and did not factor out the 3, you would have come up with one of two solutions. You would have either come up with 3n plus 6 times n plus 1 for being a factored solution, or you would have come up with 3n plus 3 times n plus 2 for your solutions. Two of them would have come out, but if you would have noticed, neither one of those two would have been factored completely, because in order to do that, you can factor out a 3 out of those. All right, moving on. If you didn't, by the way, if you didn't understand completely what I was saying there, you may want to come and see me tomorrow morning before school. All right. We're not going to go through these too bad, but very first step, what would you do right here? If you said a diamond or rectangle, you're wrong. If you said multiply this one together by that one, no. Very first step is you can factor out a 2 out of all 3 of these before you start factoring whichever method you choose. Very first step here. They have nothing in common to factor out, so if you said for this one, 5p squared times negative 10 is negative 50p squared for the top, negative 23 for the bottom, and start doing your diamond and rectangle, you would have been correct. Very first step for 3. If you said factor out a 5 right away, you would have been correct. And very first step here. You should have said take those two, put them together in a diamond, and then that one goes on the bottom, because there's nothing that could be factored out here. All right. Next problem. I don't know if 35 I'm doing anything with. Oh, here they're just getting to this whole thing of what can you factor out of all three of those. They're kind of getting to that point, which I've already taken you to. So moving on. Right here. Here's what I want you to do. Pause the video and do these 4 problems real quick. Make sure you understand how to factor these. Go ahead and pause it. All right, we're back. You should be able to show me your answers that you got to each of those. Notice that you could factor a 5 out of this first one. The second one confuses people sometimes because they forget that, oh, it had an x in all 3 terms. So you not only could factor out the 3, but you could factor out the x before you then factored the rest of it. This one right here, you could factor out a 2. By the way, I might notice something weird about that one right there. You notice that these are just opposites of each other, a -5 and a +5, which when I had the exact same thing, I cut out that middle x term. The negatives here cancel out the positives from there. And then finally, what could you factor out of here right away? Hopefully, you said a y. Then you could factor it from there. Hopefully that all makes sense. We will see you tomorrow. This kind of covers about 3 different lessons right here. We'll see you tomorrow, and right about now, I'm assuming there are many questions. This is a really good time to start asking Mr. Anderson. Bye-bye.